Good afternoon.
I guess that means we're starting.
Yeah, that's right.
Let me press the start button.
Go. Roast is ready in an hour.
Good.
So, thank you for coming along. My name's Stu Fox, and I'm very privileged to be joined by my good friend Rick here.
that's stretching it a bit. Privileged. Thank you for joining us in this particular session about Azure Compute and Networking Update. I'm Rick Claus, Mr. Stu Fox. I made I don't know if it's a precarious mistake or a fortunate mistake of mentioning on Twitter at one point in time, hey, Stu, do you want to do a session together? And he said yes.
I'm always up for doing half the work.
That's generally how things work. So we're going to be here talking to you about all the changes and updates, what's been going on inside the IT industry, it's specifically around Azure Compute, and also, just to throw stuff in, networking.
Networking
as well.
Absolutely. A bit at the end there. Hopefully we've got time.
Yes.
So I guess how many of you were here at Jaren's session just now? There is a little bit of crossover, which, of course, we carefully planned for.
And we do ours better, we think,
Yes.
so we'll find out.
That's right. So look, I guess software's eating the world. Anyone heard this? There's another, this is Mark Anderson, I think, he said this, software's eating the world, and he wrote another one about 5 years later and said software's still eating the world. And I guess what he's saying is Uber's come along and Airbnb, and they don't own anything, but they're just these software companies, and all they have is an app on their phone, and they're basically destroying established industries. Tax industries are being eaten up by Uber, which is a good thing given the $2.30 they charge me every time I use my credit card. But what that means is that every company is a software company. And Jaren, if you're in Jaren's session, he talked about Rolls-Royce. Rolls-Royce don't just make expensive cars for rich old dudes to drive around in. They make fantastically massive engines that fly wreck all around the world. And they've turned into a software company because all those engines are generating tons and tons of data, and they're analysing that and providing value back to their customers. So but it might be a supermarket. You might be analysing customer patterns through your store. Every company is a software company.
Question for you is, for the people in the room, how many people look after software development and look after software dev teams inside of your environment right now? Put up your hand, nice and proud. There you go. Everybody else, what do? Keep the lights on, make sure the servers are working, infrastructure's flowing, desktops are working, the rest of the stuff that's the nuts and bolts of what has to happen to make companies successful. That's the part that we're the most interested in, on top of the fact that you're going to be asked questions about this whole new world of work with regards to how to transform your company to be much more agile, much more software aware, much more of a software dev focused. And so most of my career, I've been working in an environment like Stu, where we deal with looking after servers, looking after infrastructure, designing infrastructure, and then we get called in with these side meetings. I'm sure this happens to you as well. Hey, we got this app that's coming out, we got this thing that's going on, we got this project, but it's really slow, or something's not working, or whatever happens to be, just it doesn't seem to be quite where it needs to be on the proper scale of things. So
we think it's the network.
We think it's the network. It could be the network, or it could be the users, or maybe the database is set up wrong, or maybe the IOPS are incorrect. No, that's wrong. They would never say the IOPS are incorrect. We would tell them the IOPS are incorrect. But this is the kind of the angle that we're going to be taking about today, because really, this is all about, are you ready to answer these kind of questions? Are you ready to be an advocate for what's coming down the pipe with regards to transformations inside the industry, with regards to using compute technology inside of cloud environments? This is the kind of thing that we've been talking about now for a number of years. And so I actually work on the Azure Compute team. I was about to press this button. It's supposed to be this one right here. There we go. On the Azure Compute team. I transitioned out of my current role into the one that I'm in right now, where I'm now working in the team that actually builds a lot of these different services back up inside of Corp. And so I have the most comfort and knowledge about the stuff that's going on inside the virtual machine world, inside the scale sets world, inside the containers world, and that sort of stuff. But then this also goes on beyond that as well. And so I found it's been very valuable to be able to come in and have a knowledgeable position and information about all these different things when those hallway conversations happen with regards to using these new technologies, being more of a proactive advocate of these different technologies as opposed to a reactive naysayer for what they are.
Look, I think what we want to do in this session is give you kind of a good overview of all the stuff we've been doing, so you can at least be slightly informed, and then we've got pointers off to a whole bunch of other sessions around during the week that you'll be able to go to and get deeper into. So were we going to start with a demo, Rick? Or should we bother?
Well, you know what? We started a little bit late. Do you want to do a demo, quick one of a deploy?
Well, we could do a quick deploy.
Okay, you're one.
Am I one?
You got it.
I got it?
Voila.
Awesome. I'm going to do
PowerShell. You guys are used to PowerShell? You're all good? Yeah. Perfect. That's what we need to have, some energy. That man had one of these right here before he came in the room. I grabbed one as well, but it was piss warm.
How warm, Rick?
So what are you typing there?
So what I'm going to do, back to me.
Yeah.
What I'm going to do is I'm going to create a new Azure resource group, and hopefully it's going to happen very quickly. And I'm also going to create a new Azure deployment, and I'm going to create that deployment. It's going to deploy for me a virtual network, my storage accounts, and my virtual machines. I'm going to use it a bit later on in the demo, so probably a good thing I'm doing it now. And what this is leveraging is saying, well, look, we're leveraging existing skills I have, PowerShell. I'm getting a bit fancier because I'm using our Azure template language, and I don't have a reference to it in our slide deck, but there is a session on ARM templates, and Neil's delivering that.
Yeah, Neil's doing that one.
Neil's doing that one. I think that's in the next couple of days. Neil's doing a session on ARM templates, which is how you can drive this thing treating infrastructure as code. And, you know, it's a bit of a buzzword, you know, and there'll be a lot of bingo buzzwords in our session, but infrastructure as code, Neil will be talking about Azure ARM templates, and so that's how I'm going to drive this thing. A couple of lines of PowerShell, and I'm going to be
keep on typing.
Way to go. Keep on typing. Yeah, I've got to.
You got it.
No.
So essentially, PowerShell skills, all the same issues with typing that you've had before. Instead of managing on-premises technology, managing technology inside the cloud environment. I'm assuming that you've already authenticated and logged in before.
I have.
There you go.
Indeed.
You're good. And I'm amazed that he's able to remember all these specific references.
Now I'm getting stuck, aren't I?
There we go.
See, it's all working. It's all part of my plan.
You got it. So in case you missed on this, he mentioned the fact that he's using a template language using JSON file. The JSON file is simply a text file that describes all the different resources you're calling upon, putting them together correctly in the proper order with the proper configurations. It's the start of this buzzword thing that people have been referencing and talking about in the DevOps world, known as infrastructure as code, to be able to basically describe your infrastructure down to the finite, minutest little point, checking in the source code if you need to, throwing it up, and then actually going and deploying, and off it goes.
Cool.
How's that going to run?
That's going to run for a while, and that's eventually going to spin up some stuff in here, and we'll have a look at that a little bit later on. But what we're doing, leveraging existing skills, but enhancing the stuff we're doing. I guess Rick and I talked about this yesterday, that we started, I don't know how long ago, with PowerShell, and we started slowly making it more and more part of the product. So Exchange, you had to know PowerShell to do Exchange. And then we've started introducing PowerShell desired state configuration to do configuration management. Now we're kind of leveraging that as well as the new Azure ARM templates to kind of make all that stuff a great big lovely picture. Existing skills, reuse them inside the new world of work and new way of doing things to be able to go ahead and move forward. Speaking of moving forward, we got to keep on going with the slide deck to basically mention the fact that we've got these things called regions. 38 different regions around the world. There's 34 in the last slide. We just opened up 4 new ones since the last session. That's how fast they're going. We're basically making multi-billion-dollar investments on new locations and facilities, as well as expanding existing ones as well. 30 different regions around the world. We don't like to say data centers because usually a region is multiple data centers for fault tolerance capabilities. And so 30 different regions around the world. I'm quite happy about the new one they opened up in Canada. That's not been that long ago. Latest one's the UK, the German one, which was also the sovereign cloud. And we've got France and Korea coming online. So this guy here is an example of the one from Virginia. Which is an example of different modes of different ages of data centers that happen to be used inside of Azure. As one example. Interesting note, they've got a fence all the way around there. We actually have teams that are responsible for building and testing these fences to make sure that they withstand a Ford F-350 at full speed crashing into this fence to make sure it doesn't actually shatter or break or give way. I just thought that was kind of cool. Yeah, so I like crashing cars. Come the zombie apocalypse, I think that's going to be the place to be, isn't it? For size and reference, that's an actual 18-wheeler down the bottom corner over there as far as a truck is concerned, size-wise. One of the levels of expansion that just happened was this guy here. You can see the new modular format that we're using with one of our Gen 4s as far as our data center is concerned. And then the optional place. And you actually said about the amount of endangered species and wildlife that's potentially being endangered by this. Home of any number of dangerous bears and coyotes. This is 5 square kilometers in size. The expansion for one of our 38 data centers that's there. I recently took a data center tour on the eastern side of Washington, and at one location, that particular location had 150 acres in size for the existing data center, which was 2 sections of 6-foot football pitches side by side, so basically 12 in total.
And then if you looked over to your right, that's another 350 acres that's going online next month from a size and, again, scope of how fast we're growing these things. So we have some substantial locations and regions you can go off and deploy in.
Rick had to ask me if we had acres here, because,
Is it hectares?
Acres.
Acres? Acres works. So from infrastructure perspective, it's the easiest place to start from our background for the commonality of understanding virtual machines and virtualization on-premises technology, moving up inside of the Azure cloud environment. So we're going to start off a little bit about talking about infrastructure and compute. That's the foundation for all this other stuff that becomes much more powerful, which we'll also be talking about today. I have a session on scale sets. I've got a session on container services later on this week. We'll touch on some of those later on today. But then on top of that, we have this extra piece of information with regards to scaling, orchestration, and also infrastructure as a whole for where things are. That's the clicker. Here you go. You got to keep on going that way.
Cool. So
virtual machines.
Virtual machines. So obviously, there must be someone here who hasn't used Azure yet.
At least one person. Yes. One person has not used Azure yet. Wow. Nice to see you, sir. Thanks for coming at the session.
Sorry, I think you might have just wandered in off the street.
Yeah.
Lost.
Actually,
I mean to find the Baccarat tables.
The Baccarat tables in the back, sir, in the corner. You should have turned left instead of right.
Yeah. What have I come into? This is the strangest gambling I've ever been in. So look, we've got a whole bunch of virtual machines out there. It's one of the biggest bits of what we do. And we can run pretty much anything now. Anything x86 we've got. Ubuntu, Red Hat, Windows, SUSE, CoreOS. I mean, Rick works in the open source team, and he'd be able to tell you all the work that's going on there to make sure that Linux is a first-class citizen on Azure. And then we can take, we take all our DevOps processes with Chef, Puppet, Ansible, Salt, choice is yours really, and run those on virtual machines as well. Multiple sizes, and we'll get onto that in a second. And we've got hundreds and hundreds of items in our marketplace. So, and to give you an example of what that might be.
You don't have to deploy a blank machine, obviously. Yeah. This, again, if you've never done this before, you can obviously go ahead and deploy one of these pre-configured machines from our partners, ones that we've made ourselves, or basically almost anything under the sun. They've been growing and growing and growing from the Azure marketplace.
You want a checkpoint firewall, you want Hortonworks Big Data, you want, I don't know.
Some Veeam backup software is in there, Riverbed for appliance, IDS systems as well, antivirus. All sort of stuff is available inside of the marketplace.
Yeah. So, look, there's a lot of stuff we're doing there, and a lot of vendors we're working with, and we work really closely with them. So in terms of VM sizes, I guess this is a snapshot of where we were, I don't know, maybe 6 months ago. We had A series, which are kind of our value SKU, so where you don't need a high level of CPU power, but you want to pay kind of a lower cost for it. That's where the A series come in. And they're good for things like your domain controllers, or we need to scale out web servers and those kinds of things. Then we had the D series, which brought in local SSD storage and faster CPU. And then we've evolved that into our DV2 series, which is basically the same as the Ds, but with faster, newer processors. And so if you're deploying today on Ds, you should probably just move to the DV2s. We're charging you the same amount for them, and they're faster machines. And then we had the G series, which are kind of our monster VMs. And so if you wanted to get up to a 32-core machine with 448 gigs of RAM, then that's where you'd go to run these kind of monster machines.
So think about that from again, server hugger perspective, racking and deploying servers. I used to have to go off and buy systems that were as large as those G5s. Used to take, if you went to one of our partner websites, we'll go off and order one of these things, upwards of $70,000 to buy one G5 series machine. It would arrive in 11 to 15 days after it's ordered and approved, and then it would take you another 2 or 3 days to get it racked up and ready to go, and then software installed. You're 17, 18 business days before you actually can use that particular box, before it's already started depreciating. A G5 could have been deployed by the time that he started to talk about it, and then I now talk about it now, would have been finished by then, and you can actually go off and use it inside of our data centers. So very fast, instantaneous access to those very powerful machines, and they also are able to be billed by the minute. Only turned on and used, deallocated, you're not paying for that box anymore. But we've evolved, and based on customer input and specific workloads, a whole range of other types of machines have now become available as well. Some of the F series that are very compute intensive, they don't have a lot of RAM associated with them. They've got mostly more CPU power and less less drive space attached up to them. The L series is now coming out in the near future, talking about having more large onboard storage good for different temp space and good for different database type access. We also have the H series coming out, which has even faster CPUs that are out there, but then also high-speed networks. And then we're purposely avoiding talking about these lovely N guys, because there's a whole session just on these NVIDIA accelerated N-series machines, compute-intensive workloads and visualization-intensive workloads that are now available. They're super freaking cool. You can go off and look at them. That's M215, done by a good friend, Karan, who I think is here, potentially. He was. There he is in the upper back corner up there. He's going to be talking about the N-series and has some awesome demos. People talk about those guys there for what they're there for big GPU-intensive compute workloads and visualization workloads.
And look, we've been talking to a lot of customers locally about using them for research purposes. You know, a lot of research or machine learning style things run on these kind of NC series, the K80s, or then you've got your visualization to run your AutoCADs and those kinds of things. But yeah, Karan will talk all about that. And I guess the other thing is, you know, the H series is the HPC series compute. So they've got fast CPU, lots of RAM, and RDMA connectivity between them. So if you're doing kind of big compute analysis and you need to pass messages in between these machines, then the H series is where you want to go. And so they're quite new. They're still going through a global rollout, so we haven't seen them in Australia yet, because that's obviously the data center we all care about, right?
They're out there. I can hear them.
Yeah, I know.
That's good.
I think they're learning how to...
Yeah, that could work. Learn how to interact.
Yeah, that's right.
So building on top of a generic VM, we actually have these different services that we're able to now provide, because we have this base layer of infrastructure, a fabric that we can now go off and use. Build on top of that, you get some value-added services. One of these things is called a scale set. I've got a whole session on scale sets coming up, but I wanted to just give you a quick little glimpse about what the concept is. Picture yourself that you've now been involved in one of these hallway conversations, talking about this new app or this new line of business app that you want to go off and now modernize for a cloud environment hosted inside of Azure. And you've managed to talk with the devs and talk with the dev teams, and you've gotten it now so you can abstract out the, let's say, the web layer, the web tier, the app tier, out and away from the data tier and from the control plane. And you need to be able to now have a load balancer in front of that, but then you want to have this massive amount of flexibility for how much compute is going to be used by that load balancer going and talking to that application layer or that web layer. A scale set is the best way to go off and handle that and be able to work with it. It gives you the ability to have a customized VM that goes up and has automation that kicks in after the fact, but it's a full stack VM that deploys and then shrinks or grows as required for the number in and out that you happen to have. Or you can even go through and increase the size of the VMs up and down if you needed to as well through a different definition. And so scale sets is there. Do we have the demo slide handy, or do I have to go off and advance it? Okay, here's my session, M378.
You might have to duck so you can see.
You got it. Thursday at 4:15. But I thought I would give you a quick little show and tell. If I remember, which one am I on here? 7?
7? Or is that one?
No, it's 5. Yes.
Counting's hard.
Got it. 5. There you go. So this is the portal that is up and running. I've already deployed a scale set. You can see there's been some workload going on right now on my quick little sample demo machine. This is a template you can deploy that's known as the VM scale set demo that has a bottle application, which is a little tiny Python application going and doing some work. And so you can see here that I've actually got CPU growth and work happening around 40-50%. There was a big drop in CPU utilization because I killed one of the scale set boxes, and so the CPU went down, and then the workload came back up again and keeps on working and basically just goes. The idea behind a scale set is based on your parameters can be simple as simply CPU utilization, or it can be schedule-based, or it can be a wide variety of different types of indicators that are there. You can go through and increase and decrease stuff. If I take a look right now, I've got only 2 instances running for this particular environment right now. I want to go off and, instead of placing an artificial workload on this box and making it go even higher to scale up, I thought I would show you a little bit about the rules that exist right now. I'm using this tool called Resource Explorer, called resources.azure.com. If you're not familiar with this, it's very handy to see what's actually going on inside your subscription, inside the JSON files that go off and describe this. I'm going through my resource groups. I've got my bottle demo, and I'm going inside my Azure Compute environment here. Inside my Azure Compute environment, under Insights, in case you're interested, this is where the auto scale settings are actually stored. And you can see here that I have to have a minimum of 1 up to a maximum of 10, and I'm going to default only going off and using 1. I'm looking for when processor time goes greater than 60, go ahead and increment it by 1. That's a very simple concept of a rule. You build this using the portal, or you can do a command line stuff to be able to do it.
That's
the
pretty
end
cool,
result,
right? That's basically just some random Windows performance counter. So.
You got it, and it works.
Yeah.
So if I go back up here to compute for my bottle demo, I can see here that I've got a capacity of 2 right now. If I go in here and say edit and change this guy from 2 to 20, and I say put, which basically goes in and updates the model my scale set's based on, it's now going to go off and interpret that, hey, an API call was made that says increase my scale set from active 2 to active 20 and go ahead and start to provision those boxes. Coming back over here, I already showed it there.
Yeah.
Coming back over here, I'm basically doing a manual run of a new rule, and you'll see that I've got all these other machines, 20 of them to be exact, that are now spinning up and being created, exactly identical to the ones I had before, that has an automation workload after it's been deployed that goes off and runs this bottle application to go off and do some more work to be able to get this guy done. Notice it's still being created. These are full VMs that are being spun up. As the workload is no longer required, the automation would actually kick in and say, hey, by the way, I'm not at 60% anymore. I'm way below 60%, so start killing these guys off again. This is the epitome of using servers as cattle, not as pets and individual snowflakes. They are completely expendable. I don't care if they get created or deleted on the fly. This will automatically adjust for me.
Look how fast.
Look at that. They're back up and now going, and they're now started. Quick. If I absolutely want to take one last little thing here, just quickly, I'll just show you the logs. The logs will go off and show you here that you have the actual work going in for the last 6 hours, and show you the logs across all those different systems to basically say, hey, I've got scale down operations now taking place. I've got scale up operations taking place. And I've got the actual scale sets now going up and going down in size. So some good stuff you can go off and do some reporting on. Introduction to scale sets. I do a lot more depth talk about scale sets and how you work them, how you use them, different examples, and that sort of stuff coming up in my session on Thursday.
Cool. Isn't that awesome?
Yay.
They're blown away. They're stunned. It's stunned silence.
They're stunned silence.
So I guess the next bit is Azure Batch. So we talked about scale sets and being able to scale up and down. What about if you said I've got a job that I need to split across 10,000 cores and I want to run that job? Well, Azure Batch gives you the ability to do that. So leveraging the compute platform, but provide the smarts on top to orchestrate running that job across all those cores, scaling that up and down. Giving you letting it, we'll manage that stuff for you. You give us the job, and the batch part will take care of the running up the VMs, getting your workload onto them, and then and dealing with running that stuff. And then you'll basically pay for that 10,000 core workload. It'll run for as long as it runs, and then they'll all get turned off, and you'll be good to go. And so we're actually quite lucky in New Zealand because Azure Batch is pretty much a New Zealand product. It's from the Green Button team, and there may be even a couple of members of the Green Button team here. Maybe. Oh, yeah, up the back there, a couple of them. They don't like to admit that they work here at all. So these guys build this stuff for us. And so again, if you need to run, I think that's called embarrassingly parallel. Is that the right word I'm using? Embarrassingly parallel. So you need to run those jobs that can run simultaneously across 10,000 nodes or whatever it happens to be. I don't know if any of you were at the keynote. It might have been last year, maybe the year before. Dave Fellows did a rendering demo. Using Azure Batch. That's what we're doing there.
Interesting thing is, again, Batch is built on top of things like scale sets. Again, we're incrementing the value on top of the different services that we're already building and working with. Containers is the next one that's nice and hot and hot topic these days. We're
almost at bingo, right?
Almost at bingo. Almost got a straight line. Yeah. But the idea with containers is it gives you the ability to be very fast and agile with the way that you want to go off and deploy and work with different workloads. The best thing about it is that you're able to use industry standard, very open source and community-driven terminology and standards. An example that we use that we've adopted in our technology, both on Windows Server and also on Azure, is using the Docker container format and how that works. But it also goes ahead and defeats the whole concept of works on my workstation, because you literally can go off and build your environment off the different containers, off of the workstations, take those exact same containers, put them inside of a repo, and then go and push them up into the different areas you want to on potentially even different cloud providers as well. So you have your dev environment, your dev and test, and also prod. for those different containers and where they happen to all fit. Containers is the next evolution for where things are going. It's got a very big following and a big community that's been there. Containers is one of those things that also isn't new. It's been around the Linux world for quite some time. What is the relatively new stuff that people are very excited about is this level of standardization and this level of tooling that we can all now go off and use across different platforms to bring it all together as one nice, comfy, cozy ecosystem that happens to be there. The concept for how containers works is that you have your traditional virtual machine as one example that we've all been using for quite some time. You got the hardware layer, and above that, you've got your virtualization layer that virtualizes the hardware for the virtual machines. You have to have a full OS, you got your application, and everything else running inside of that full VM. You saw how slow, potentially, it was to get those VMs created on that scale set because they were full-fledged VMs. If I was doing containers instead, it would have been much, much faster because containers don't have that same level of infrastructure required because they have a runtime environment and they have just basically the container application running on top of that that interfaces with the engine to be able to go off and to work. So basically the OS is shared amongst those different systems. They still have a level of isolation and compartmentalization, if you will, because they are containers. So it makes it very, very fast to be able to go off and to deploy and to manage and to work and to standardize on things.
I seem to remember we did this thing called AppV many, many years ago, Rick. almost looks the same to me.
It's not. Different technology, different technologies. Windows Server Containers is something that's basically now out with 2016. Just went GA a little while ago, where we have announced that we're using the exact same tools, Docker Engine and Docker command line tools, to be able to go off and to manage and work with those, which is awesome that we went that route. And we work very closely with Docker to be able to make it so that their libraries will work. And we present libraries from Windows Server that's very similar to how they're presented at the OS layer for being able to talk to those different systems. But then we also have Hyper-V containers, where it's like a hybrid version of these specific to the Windows environments on top of a Hyper-V host, which works with even more isolation and some good performance. I'm here to talk specifically about the Azure Container Service, but there is a session specifically on Windows containers, the advantages that you have in using them, and where they are and how they work, taking place on Wednesday, 4:15. It's the M402 Windows containers. Who's doing that one there?
That's Ben Armstrong.
Oh, Mr. Armstrong, of course.
So, he's the guy who runs the team that does that stuff, so he should probably know a little bit about it.
Just a little bit. Just a little bit. ACS, or Azure Container Service. This is one of the services that's built on top of the scale sets concept for how it works. It's completely built using open source technologies, made available to you to use inside of your subscription, and allows you to go through and use standard Docker tooling and APIs that you would expect to use on your own on-premises work and your own open source environments. That's where you happen to work on. And then allows you to go ahead and choose your orchestrator. We'll talk more about this in the session I'm going to be delivering coming up. To be able to go off and to provision these different containers inside of your environment. The neat thing about this is it also works with Linux containers for the ones we're working on, and in the near future it'll also work on these Windows Server containers as well. It will be available in the near future both on Azure and Azure Stack. It's currently available right now on the Azure world for where things sit.
What I like about the Azure Container Service is that, I guess containers came along and people went, well, deploying software is really, really hard. And so they went, oh, well, we've got containers and that will help us deploy software much more reliably. And then they went, well, actually deploying containers is really, really hard. And so we have to build a new tool to deploy containers. And so now we've got a tool that manages containers. Then we were actually managing our tool to manage containers is really, really hard because that's really complicated as well. So you've kind of got complexity that keeps moving back the chain. But what is great about Azure Container Service is that it kind of masks a lot of that complexity away from you. So you can kind of get back down to what I actually want to do is deploy containers and deploy software in containers. Yep. I don't really want to futz about with, my tools and my, DCOSs and my swarms, and I don't really need to.
So the idea is it comes right down to the level of choice for how you want to go off and work your workload with containers on top of Azure. I've got an example here just to kind of show you just a quick little 1-2 of where this is. I'm actually now SSH'd into a box on top of Azure that's running Ubuntu 14.4 and also has Docker bits installed on top of it. If I do a Docker PS, I don't have anything actually currently up and running. Do a nice simple Docker run hello world to make sure everything's working correctly. It doesn't have it locally. It goes off and actually talks to the repo to be able to download it. In this case, it has a copy of it local. It then goes up and brings up this quick little message that says, hey, your container engine and your infrastructure is working correctly on this one local box to be able to go off and to do this. Now, I'm doing this all locally to my box. If I do Docker info, you can see here that this is RJC demo VM, 6 gigs of RAM, this one little box that happens to be right here in front of you right now. If I go through and I simply do one of these export Docker host, and I change it to port 2375, I have a tunnel set up on my box to go and talk to the Azure Container Service over port 2375, and I've now just said Docker commands, go and talk to this guy instead. Now if I do a Docker info and I scroll up, you'll see that I'm actually talking to agent number 1, or 0, agent number 1, and also agent number 3 happens to be there. So I've got basically 3 different boxes that I'm now talking to up in Azure simultaneously, and I have a total of, right here, 21 gigs of RAM available to me as far as the container is concerned. I'm talking to the management layer of my orchestration engine, known as Docker Swarm. And now when I go off and I try to deploy a container to this environment, Docker run, make it detached. Let's do port 80 and do hello world. It's going to go off and say, okay, I want to go off and run this particular lamp stack that's going to go off and display a web page that lists off the system. And I just talked to my management layer. My management layer determines what is the best agent it should be deployed to. I don't care which one it is. I just simply say I need to make it go up and work that's out there. And if I want to save myself some typing, I've got in my cached history here. Where is it? Okay, I'll just type it. Too long. For I in 120 do Docker run in detached mode on port 80, and I want to run the same guy. Hello world, and I want to be done. This is going to spin up 20 instances of this. Remember how I had 20 different VMs in my scale set? Look how fast 20 different web servers come up across my container infrastructure and are now up and running. Significantly faster to initialize every single one of these individual containers, which all happen to be a web server displaying a very simple page for what it is. So containers, lean, mean, light, fast. When you use an orchestration agent like DCOS or Docker Swarm on Azure Container Services, you don't have to worry about all the clustering, high availability, the networking, the communication between those different agents. We look after that for you using one of those orchestrators instead. Extremely powerful. Mm-hmm. Come on up to my session on Thursday morning to find out more about Docker containers and about containers in general on top of ACS. Now that was cool, right? There we go. Hey, they are alive.
I finally figured it out.
Yes.
Nice. So I guess one of the things you probably should be taking away from this is that we want you to have choice in Azure. We want you to be able to basically bring whatever technology you like. And, so it doesn't matter whether you come, whether your organization comes to you and says, well, we want to do things with chefs and WordPresses and, Python and Cloudera and running on Docker, and we can go bingo. Well, it's great. We just say, yep, go for it. Azure can deliver that stuff for you. It doesn't really matter what it is. We've got, like I say, partnerships with all these vendors. We've got, you can even run PaaS on PaaS. So, we've got a great platform as a service offering inside Azure. But if you wanted to run Cloud Foundry, go for your life. We actually have a great, strong relationship with Cloud Foundry, and you can run up their environment for running Java microservices on Azure as well. So it's the choice is yours. We're not, we've got a bunch of solutions which are, effectively open source only. There's kind of no Windows stuff in there at all. So, I guess we used to be the Windows company. Rick used to be a Windows guy, and look at him in there with, Bash. I mean, he's cheating.
I got a cheat sheet in my notes. Got my notes.
He's cheating, but he's trying.
Technically, I work on the Linux team on Azure, so.
Yeah, so look, you do have the choice and flexibility to do this stuff. So I guess we've kind of looked at the kind of infrastructure piece, but there's a bunch of compute stuff that sits, I guess, in the platform world as well. And so let's have a look at a couple of those. The first one is microservices. Again, another buzzword bingo. Software's too hard. Well, we can do containers, or we could do microservices, or whatever it happens to be. And so I guess, some people, I guess, say, oh, if I'm doing Docker, I'm doing microservices. Well, not really, because you could put your great big stinking monolithic app inside a Docker container and run that. That would be fine. Doesn't make it a microservice. It just makes it a big container. So you could, but you can, containers are one of the ways you can build a microservices architecture and deploy it. The other one is Service Fabric. And so that's a Microsoft platform that we've been using for years to run services like Azure SQL DB. So, it provides the underlying infrastructure for this. And so it provides a microservices platform using either stateful or stateless microservices, and it can even orchestrate your Docker containers for you as well. We provide .NET and Java APIs for it, and we provide this on Windows Server in production and currently Linux in preview, I'm pretty sure. And the cool thing about Azure Service Fabric is actually you can take the service and deploy it on Azure, you can deploy it on Azure Stack, but you can, if you wanted to deploy it on-prem on VMware, absolutely. If you want to deploy it on OpenStack, if you're crazy, or if you want to deploy it on AWS, again, if you're crazy, but if you want to deploy it anywhere, you can deploy this stuff. So, and actually our friend Nick Ward from our Global Black Belt team is over, and he's doing a session on Service Fabric, or at least a bunch of compute stuff. He's doing a session on Service Fabric Thursday at 9 o'clock.
Yeah, if you think of the evolution, starting with simply having virtualization on premises, off of the hardware, then you go into virtualization inside of a cloud environment. Then you got now going in with the container, with a building on top of layer, which is known as the one that we're doing with scale sets, and then containers on top of that. It's almost like the progression of how you can start to look at evolving your applications that currently exist right now inside of your environments. You could easily look at trying to move them and migrate them over to a virtualized VM-style world inside of an Azure environment. You could then go the next iteration about how to make those more containerized, to make them so they're much more flexible and scalable inside of that environment. And then on top of that, the next iteration beyond that would be to be able to go in and to make them even smaller than the containers side of things, to make them into more of a microservices environment as well. It's a natural progression where things are going. It's good to know how these progressions fit into each other, how they complement each other, and when to use one versus the other.
Yeah, absolutely. So, and then we come to kind of web and mobile and event-based compute as well. And so we've got our Azure App Service, which, and those of you who are in Jaren's session, you would have seen Diego do his demo of spinning up a web app and how quickly, we could spin up a web app and, effectively managed IIS. You don't have to worry about patching or securing or making the underlying platform available. You just have to worry about having your developers write secure code, and that's like real easy, right? Right? No? But you've got the option to just deploy web apps onto this platform. We're offering you choice, because it doesn't have to be .NET. It can be .NET, it can be Java, it can be PHP, it can be Python. It doesn't really matter. We've got solutions there to let you do that. And you can, like I say, like you would have seen in Jaren's demo or Diego's demo, you can spin this thing up, have it up and running in about a minute, and it's dealt with all the stuff around scale and availability. You're just making sure your code's running properly. And so one of the bits that sits under there is a thing called Azure Functions. And Azure Functions is basically, I guess the kind of next iteration of that is, what if I just wanted to have something run periodically and triggered off an event? So it might be that I want to drop a file into Azure Blob Storage and have something happen as soon as that happens. Well, that's what Azure Function would do. And we pay per execution. We don't have compute running at all. And some people hate the term serverless. And I think my good friend Girl Germs up the back there is a good serverless hater. And there's that old saying that the cloud is just someone else's computer. In this case, there's no server for you to worry about. There's still a server there, but you don't have to worry about it. You're paying per execution.
Yeah, you're not paying for that server, I guess, a better way to explain it.
And you're not managing it. You're not dealing with any of the kind of hassle and headache that goes on with the server. You're just worrying about this thing executing. And you can write this. You can run functions in C#, Node, F#, Python, PHP, Java, Bash, Batch. And what I'm going to do is I'm going to bring on some vintage technology, and I'm going to do a demo of Azure Functions. In fact,
there you go, man.
There, cool. So, so imagine my delight, because I'm a pretty old school guy. I'm quite old. Imagine my delight when I discovered that Azure Functions supports batch files. I think, for me, this is fantastic. Like now it's a language I understand. I don't have to worry about things with sharps in them or whatever, C's or F's or whatever they are. I don't have to worry about, batch files I can get. And so I've built a particularly old school demo using Azure, using batch files, and doing a scenario that no one does anymore. And like those of you who are who are millennials, you'll go, what's a WAV file? But I'm going to use Azure Functions to rip WAV files to MP3s. Again, it's a scenario no one would do in the real world now because you're all young and you just go to go to iTunes.
These are WAV files that you own the legal rights to, correct?
Actually, I nicked it off the Windows.
Oh, okay, okay.
But so what I've got here is I've actually got a Azure function, and it's really simple. You can see it there.
Did you load Zoom it on your bot? Yes,
I did.
There we go.
It runs lame. Those of you who've done MP3 ripping will know what lame is. It's got lame, and it's going to rip a WAV file into an MP3. And it's going to do something, and there's some quite cool things about it. One of them is I can just take it and I can just drop this WAV file up to my storage account. And so it's based on a storage trigger. Eventually it will kick into life, and it might have done it already. We'll just navigate through to our MP3 container and refresh. There we go. We've got an MP3 file generated out of the WAV file using Azure Functions. So
that was fast.
That was pretty fast, right?
And 15K.
It's tiny.
It's a big song.
But it was fast. I'm only paying for the 3 seconds that ran for. And the really cool thing is that I was using a language that I was familiar with, but I'm still dealing with really modern things like Azure Storage. And so that's stored in Azure Blob Storage. But my batch file didn't have to know anything about blob storage. Azure Functions takes care of kind of abstracting a whole bunch of that stuff away from me as well. So instead of having to go, I need to write an API call to pull out the blob and blah, 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 it deals with all that stuff for me. And then getting the output and sticking the MP3 file into that container as well, it's dealt with all that stuff for me, and it's kind of made it really, really simple. And so that's kind of, I guess, my demo, which I call Vintage Tech with Stu.
Vintage Tech with Stu. I don't think I've seen a batch file demo on a stage in quite a number of years.
You know why that is, Rix? Because no one's daring enough to do it.
Nice.
And look, hey, if you want to learn about Azure Functions, our own Vishesh from Microsoft New Zealand is doing a session on Friday at 10:30. So go along and see that. He will talk you through a bit more detail. He probably won't be using batch, so that's going to be a little bit disappointing for you. But otherwise, yeah, look, he'll do a great job. He'll probably show you some modern language like C# or something.
Oh yeah.
Yeah, it's a bit dull, really, isn't it? Doesn't have the thrill of batch. So look, serverless compute, no server management, no server patching. You don't have to worry about scaling out in servers. You just run this thing and it will deal with the scale and all that stuff.
So you're literally bypassing the whole billing by the minute, and you're now going billing by the transaction.
Yep.
For that guy.
And it's a great way to do it. So I guess that's the kind of final piece of microservices with Azure. So what we'll do in the last 15 minutes or so is move on to networking. And actually it should be quite quick. So I guess the networking piece, just to recap, Azure Virtual Networks. A virtual network you create in Azure using your address range, your subnet layout. It's yours, it's isolated. You basically do what you want in there, drop VMs in there, and you secure it using, you can create infrastructures like you do on-prem. You can have a DMZ and backend subnets and do all that kind of stuff. And then you can secure it using platform features like network security groups, which we added probably 6 or 9 months ago. And so network security groups allow you to provide effectively stateful rules to control traffic going between your VNets or between subnets and your VNet. And you can apply those on subnets, you can apply them on virtual machines or virtual machine network interfaces. Some people really like that because it's platform based, and so you don't have to worry about buying firewalls and things. But you also might want to do things like drop in a virtual appliance. So like our partner vendors, you might drop in a Barracuda or a Checkpoint or something, or a FortiGate. And you want to override the default routing that Azure does. We use these user-defined routes to do stuff there as well. And so that's, again, functionality from kind of the last 9 months, I suppose.
And it's important to note that, as you mentioned, it's software-based, which means that it's also able to be declarative inside of these JSON files. That's part of your overall project for when you're going off and building your infrastructure. Check this into code. Make it so that it's got source control on it so that you're able to go off and redeploy as required. It's always going to be done the same way. None of this manual configuration or automation or scripted configuration has to happen. It simply is defined at that one initial piece. Very good.
And I don't know what you guys see out there, but I kind of consider networking as the last bastion of the old school world, with these kind of wizards sitting there with their little command lines doing strange things with SSH that no other human being can understand. Linux, great, get that, but the network world's still kind of stuck in this, I don't know, wizard world. That's just my opinion. Well, yeah, I'll tell you, so I was talking to a customer a while back, and he said their networking infrastructure is so complicated that when he raises a change request for a firewall change, he raises two. He raises one change request for the first change window, and he raises the second change request for the next change window. And the first one is for the network team to put the change in, and the second change request is for them to fix it. And he does it every time, and they never fail to disappoint him.
He's covering his bases, basically.
He's got it
sorted. Is that how it is?
And that made me laugh. So look, we've got software load balancer in there now. That also now, we've had that there for a long time. That now has an internal load balancer as well. So if you're load balancing internal apps, you can do all that stuff. And then we can do VNet to VNet connectivity, and we've also got, obviously we've got our connectivity through to Azure using our software-based VPN or our ExpressRoute service through our various telco partners. And we have got a couple of people from the ExpressRoute team in Auckland for Ignite. If you want to have a chat to them, if you're a networking partner or a general partner that want to have a chat to someone from the ExpressRoute team, come and grab me, because I'll introduce you to them. I don't know whether Lena's in here or not, or Jay. But they are around, and we'll be able to connect you up with them. So that's kind of where we were probably 9 months ago. Some of the stuff we've done just lately, and in fact, some of the stuff we've just announced at Ignite last month in the US, one of the things was this network speed enhancements. And so we did a big thing about how we're starting to use field programmable gateway arrays in Azure to provide speed enhancements, and some of them up to 25 to 30% speed enhancements of kind of inter-VM connectivity. And so there's kind of some nice stuff that will be happening as we kind of, and the rollout for that should be completed by the end of the year, I think. And there'll be kind of a bit of an update of some of our VM sizing about what bandwidth things have. But that's kind of a great little thing that we're enhancing the platform, and you get to take advantage of it without really having to do anything. It just happens. One of the other things we also announced was a thing called accelerated networking. We were able to use single root I/O virtualization in the hosts to provide offload of network stuff to the network card, and in some cases delivery up to 25 gigabits per second of network speed. And so that's available in preview now in some regions on the D15 size VMs. And I guess that'll kind of expand that over time, but that involves installing the right driver and things. But that'll be available. And so again, for workloads where you need to deliver a lot of throughput, this is going to be a great thing. VNet peering, we announced recently, and I'll show you a demo of this, but this is basically the ability to take two virtual networks in a region and just hook them together, and that hooks them together at the back end, and you don't have to worry about VPN gateways or anything. You've just got these virtual networks hooked up. MAC persistence, which is a big one. A lot of people have been asking for things like license servers, because VMs in Azure used to reboot and change their MAC address. Now if they reboot, they keep their MAC address, so you can run your license server, which is locked to a MAC address, and everyone's happy again. That's a good thing. IPv6 inbound via load balancer, and we've added some network diagnostic stuff, which I'll show you as well. So let me flick over to the demo, Rick. So I did say I would show you. I would use so we created, you ran that command before, and we created a bunch of resources. We created some machines and things. And what I'm going to do is show you how easy it is to set up VNet peering, and also show you some of the, quickly show you the diagnostics piece. So the VNet peering piece, I've got a virtual network here. And I can just come into the portal, and hopefully you can see this reasonably clearly. There's a peerings button there. And if I just go add, and I will just choose my virtual network, and I'll go Ignite VNet because that's the one I created, and go OK. I'll give it Ignite Peering. Everything's got to have a name, doesn't it? Oops. Ignite Peering, and go OK. And it's going to go off, and that's how simple it is to connect two virtual networks together in Azure.
No gateway.
No gateway.
No VPN configured. No additional charges.
Nothing.
Just peers it up.
And the cool thing, this was all sitting inside my subscription, so I was able to just hook that thing straight up. If I'm talking about two separate subscriptions, I can still do it. There's just two more steps to kind of swap authorizations, basically. So it's as easy as that to connect two virtual networks together in Azure now, which means, and one of the scenarios you might think about using this for is if you wanted to do something like control all outgoing internet traffic via a single virtual network appliance. You could run that in a central virtual network and have other VNets paired off it and have them all routing through that one central network. That's kind of one of the scenarios you could look at doing for that. So that's kind of nice. Actually, there's a and then the other bit was, what was I going to show you? I was going to show you some of the troubleshooting stuff.
Yep.
So let me find, where am I going? I am going to subnets. And, let me see. Troubleshooting has gone. Oh, that's not great. Let's have a look. That is really interesting.
Monitoring diagram.
Yeah, there used to be a little button down here. Yesterday, in fact. I was going to show you that, but I guess I won't be today. They must be mucking around with it. The trouble is I'm on a... Actually, I wonder if I can go back to... no, I don't know how to go back to the old portal. That's interesting. I was going to show you... one of the things we've done is around making it easy to surface up things like the effective route table and the effective firewall rules that are applying to a virtual machine or to a virtual machine subnet. So, in fact, I wonder if we can see it via the virtual machine. No, we don't see it there either. So one of the things is well, hopefully it'll come back. I am on a Microsoft portal, but hopefully it will come back. What we're doing is surfacing up some of the things. So when you look at a VM, you can see in the portal all the rules the effective rules that are applying to it. So the kind of the combination of the various network security groups that are applying to it and where the kind of denies are. So I can see at a glance where traffic's being blocked, or I can see why traffic's going in a different direction than I thought it might. So you can see all the user-defined routes that are applying to each. To each VM. So I was going to show you that, but obviously that's not going to work for me. So we'll end the demo there. It's always got to be one that fails, right?
It was optimized.
Optimized, yeah, optimized for speed.
Optimized for time.
Yeah. So look, I guess what's going to happen in the future, we will have more regions, I'm sure of that. We will have more sizes. There will be more services. And there'll be lots and lots and lots more stuff. Lots and lots of stuff.
Yep. The innovation that's happening inside of this type of environment is growing every single day, for sure. I can tell you that. I just joined the team for Azure Compute about 9 months ago, and there's been radical changes that have happened just with even the last couple of months, let alone the last 9 months that I've been there. And it's only going to continue to evolve and to progress as we go. We're making multiple billion-dollar investments on a regular basis in this type of infrastructure. If you're talking to other providers that are talking about being cloud providers and they're not making these size of investments, they're not going to be able to grow and to keep pace with the players that are currently inside of the Magic Quadrant right now. And it's very exciting to see this all grow and go. As we talked about from the very beginning, showing you the entry-level stuff of just getting your feet wet, understanding simply how to provision machines using existing skills and tools for virtualization and for VMs, but then building upon that to be able to be more complex and working with scale sets and then container services built on top of scale sets. It gives you a lot of flexibility to start to inject yourself inside of some of these conversations. When you're able to talk about some of these different technologies, understand the concepts behind them, and to play with them, and to be able to bring that information to light during these conversations, you all of a sudden become more of a differentiated individual inside of your organization, as opposed to a naysayer individual that may have been blocking these different types of solutions. Not all the different things that we've shown you today, the sizes of machines, that sort of stuff, are available in every single region. They go based on where we think our customers need to have these different innovations and these different technologies. And so things will continue to grow and to expand as we go. We've also given you some ideas on sessions to go off and get some much bigger and deeper details throughout every single one of these topics for the rest of this week. You've got some more too as well, correct? Or is this your only one?
No, that's it.
This is your only one?
This is my only one.
You got off easy, man.
I know. Especially when you volunteer to do half of it for me. I mentioned my delight.
I'm the glorified button presser over here is what I've been doing for that one there.
You're doing a great job.
We are going to give you 5 minutes back of your time. We will be able to take some questions if you're interested to stick around and to do stuff. There are some phenomenal opportunities to connect up and to network taking place tonight in the hub. And I do believe there'll be some adult and non-adult beverages available at that time as well. Always good to go off and do some architectural designs after a couple of adult beverages. But if you enjoyed this session, this content, if you enjoyed us with our back and forth that we had for an impromptu session for collaboration, please don't forget to go ahead and to fill out the evaluation forms. We really appreciate it. And you also get a chance to win prizes like the Surface Pro 4 and the Xbox One S.
Which is awesome.
Oh, yes. Stephen got a couple of them that have been specialized inside of the hub area with different gaming backgrounds, stuff like that too, so it's there. Thank you very much for taking the time to this kickoff, if you will, for the rest of Ignite, for a lot of the Azure Compute type stuff, and be sure to check out some of those other sessions from some of the other speakers all the rest of this week. Thanks for joining us.
Thanks, team.